Hey folks again, I'm Michael. I'm a committer on the vLLM project. I'm an engineering lead at Neural Magic, now a principal software engineer at Red Hat now. And yeah, I'll be here as your host and we'll be going over what's new with vLLM in the last release, covering a few special topics that have landed off that release and on main that hopefully you'll be excited about. And of course, covering a bit of the roadmap for Q1 here as we're getting started in this new year. Also following up, not to say, not to discount them, but on January 23rd, we're going to have a presentation I'm really excited about by Murali from Sentinel, who's also a committer on the project, and he'll be covering an overview of distributed inference with vLLM. Murali worked on some of the forms of parallelism in vLLM, particularly pipeline parallelism, was worked on by him back in the Llama 405B days. Not that many months ago, but it feels like a while ago. And yeah, so definitely if you're interested in model parallelism and what our plans are there for things beyond tensor parallelism and pipeline parallelism, he'd be a great voice to listen to. So if you're not familiar with vLLM already, it's a fantastic open source project. The top used open source inference server for large language models and really generative AI. So with a focus on performance and supporting as many models as possible, we define models in a PyTorch Hugging Face transformers-like interface, but have many optimizations to apply state-of-the-art inference acceleration research and get those models working on various hardware backends. So of course, getting good performance on NVIDIA GPUs, competitive with TensorRT, but of course, also getting the models running on AMD GPUs, Google TPUs, AWS, Intel accelerators, and expanding to Tenstorrent and Huawei Ascend soon here. Also CPUs. I'll cover more than just x86 CPUs here in a few slides. And yeah, within that, we have a lot of inference features, of course, not just text-only inference models, multimodal, embedding, reward modeling. We hope to, well, yeah, we'll get into the what we hope to in the roadmap. Many forms of quantization. One of the key things that we brought in was activation quantization. Which is a really big benefit for actual production serving workloads, as that's the focus of vLLM. And of course, system level optimizations for more efficient scheduling of, concurrent requests coming in from a live service, which vLLM is most often used for, like chunk prefill and prefix caching, and supporting multiple LoRa adapters for single models, so you can host multiple fine-tuned models effectively. And of course, user features or API features that you get from some of the big APIs, like tool or function calling, or structured outputs, like we already went over, and all the fun types of parallelism that we're hoping to expand. Yeah, what we do at Neural Magic is we contribute to vLLM. We love the project. We spent the better part of last year really contributing a lot, and we love the project. We also have a sort of enterprise fork of vLLM that has, production grade, ready, stable distributions where we backport hotfixes and take care of all the boring software engineering features to make, the open source project more ready for your production deployments. And we, of course, help your organization scale in building their AI inference infrastructure from a software perspective, making sure you're, getting the best bang for your buck using the hardware that you have, so you aren't, overpaying on your hardware and not getting the performance that you need to, make an efficient service. So without further ado, let's get into what's new in the last release. This was a release really, pockmarked by DeepSeek v3 coming out over the holidays. We had a great little, push to get this support on day 1 or day 2, I think. But, you should be able to run DeepSeek v3 on, H200 system or MI300X system. with some context length restrictions. We're currently have an open issue for planned work and additional optimizations on the model. There's still some, pretty decent sized optimizations we would like to implement, like MLA and more efficient tuned kernels. But as I hinted to earlier, this is sort of the first introduction and implementation of FP8 2D block quantization, which basically means for every 128 by 128 elements of your weights, you have one scale. And so, we added in capability to our, you know, fused MOE kernel for to support this quantization, also linear layer, of course. Um, and this because the model is, I think, 685 or 600, definitely greater than 600 billion parameters. It's the only way you can kind of fit it on a single node modern system. And of course, they train the model at FP8, so that's the best way to run it. Yeah, there's been a lot of progress on the V1 engine refactor. You'll hear us continually talking about this. And we think we're basically there for a beta release. So certainly look out for a announcement there from the vLLM blog. We hope to ask a lot more people to use this, as this is definitely the future of vLLM, and both from a performance and a functionality perspective, as we plan on, really driving forward the simplicity and performance of the project in V1. We have a slight breaking change. This shouldn't really matter to many people, but there was this sort of request ID middleware that was added into the API server a while back that we realized was actually greatly hurting performance for streaming workloads under high numbers of requests, each streaming out individual tokens. So we disabled this by default, rather than enabling it by default. But if you really need this, which all it does is include a unique ID on each request or response back, then you can enable it. We also added support for the latest IBM Granite model and Jamba models for sequence classification. As we've sort of mentioned in the past, we're greatly expanding beyond just generation models, and also trying to expand support for more explicit embedding encoder decoder audio models, and classification models. So more of your traditional NLP tasks as well. And surprise, all the new Quen reasoning models work just fine. We also got finally into an actual release, the 2.4 sparsity with quantization support, that we sort of announced and put in a blog at our last session, but that was on the nightly. Now it's landed in solidly here. A pretty interesting feature for some folks that are deploying on Kubernetes or scaling systems, or on AWS specifically, as there's sort of an optimized model streamer for loading models from S3 in custom formats that gets a lot of really high performance. So if you're wanting to load models from S3, this is probably going to improve your startup times by 2 to 3 times. So if you're in need of something like that, definitely check it out as an optional model loader. Another little thing is we added a PyPy index, so you can now in a PEP official way load the commit or nightly builds with where you don't get mismatches between the version names of the wheel not matching the version and that the wheel actually is. This is important for using with tools that really respect this and enforce this, like UV. So one thing I wanted to cover that is new in this release is that sort of snuck in under the V1 improvements. We're going to continue working on this as general prefix caching for multimodal models. But since it was asked here, I think a few months ago, I can't remember who asked it specifically, but we actually have gotten this working in V1 with just prefix cache. This is sort of enabled by default in V1 now. So if you have vision language models with with images, we have prefix caching built out for this. And so I have sort of a pipeline overview of what inference for multimodal models in V1 looks like. So, right, we have like your prompt and your raw data, your raw image. That goes through processor. Usually this is a Hugging Face processor. Out of that, you get your, tokenized prompt and, your features or your actual, embeddings for the, image data coming in. Then this goes to the scheduler. Um, Oh, wait, sorry. Yeah, the features are more like the pre-processed image that's been like resized and pre-processed for the model specifications. Then the scheduler will separately schedule the token IDs, which includes sort of the placeholder tokens for the image features, and then the features go to a separate, right, encoder projector model. These are usually separated for lava style models from the decoder language model. We produce the embeddings to the encoder. This gets stored and at a embedding cache. And then as the decoder language model gets to those placeholder image tokens, it starts fetching and merging in those embeddings that were calculated from the encoder and projector. And then we have our usual, decoder KV cache that we already use for prefix caching. So, we ended up sort of modifying like these three different caches and adding this input processing cache that didn't exist before. And on the right, we have just a simple benchmark showing a Mulmo 70 billion parameter model on 4 H100s. And you can see there's a little boost from vLLM v0 to vLLM v1, even without caching, about a 40% boost in performance. And then as we go and increasing amounts, so 0 repetitions means like 0 prompts are repeated, 50% means 50% are repeated, 100% are 100% repeated. You can see we get some really good multipliers on performance when we start getting more prefix cache hits. Um, and this is because we have sort of caches at multiple levels. So if you get really lucky and you have an image cached even before it's in the preprocessor, we can match that hash and connect that all the way to the KV cache that processed, encoded, and used during decoding embedded image. We can basically like hit that incoming raw image at all three of those levels and insert that into the or just hit that and retrieve that from the KV cache. So you can really get some efficient optimizations if you have shared images in your prompts, like in multi-shot use cases or yeah. So that's pretty cool. Yeah, another little tidbit. This actually just landed on main, but it doesn't really need to be in a release because it's for building from source. But we finally have capability for building vLLM on your MacBooks or Mac Studios. So you can build sort of natively on macOS with Apple Silicon if you just install basically your usual Xcode command line tools. Um, Currently, this just leverages the ARM CPU backend, so it isn't the most performant. It's not using Metal and the NPU or Apple Neural Engine, I think is what they call it, or the GPU on your Apple device yet. Um, Hopefully, we should be able to support that through the MPS backend on PyTorch eventually. So if you're interested on working on that, happy to help guide you. But it works exactly as vLLM works on any other CPU backend. And because we don't really have to build many kernels for it at all, it's really quick for rapid iteration and building on the sort of Python parts of vLLM, or adding new model support or testing things like this. So it's definitely really convenient for a lot of us developers when we're on planes. We're looking forward to stuck without Wi-Fi to still be able to test and work on vLLM. So, um, Okay, yeah, I'll cover some of the questions after this. But as I mentioned, we wanted to go over the roadmap. So you can, this just got posted a few days ago. We've been working on it, and you can access it at roadmap.vlm.ai. It just links to the issue on GitHub. But sort of summary here, and sort of a P0, P1, P2 priority. Um, P0 definitely is our top priority, and there the first thing is obviously shipping V1 architecture, making this a first-class citizen and enabled by default. Um, and the real goals of this is to make the default performance of vLLM much, much better. So not sort of leaving you with these performance trade-offs that you maybe currently have to make in V0, or sort of inconvenient defaults that aren't getting you good performance by default. So yeah, our goal is to make just vLLM serve your model name performant. We very much want to have that as our North Star. And some other things like, um, the prefix caching being enabled by default, because we can have it such that it won't cause any performance regressions by being on or like trying to hit things in the KB cache. And similar with like speculative decoding, there's some draft free model methods like ngram, which are perfectly which are simply just looking for matches in your prompt that you're trying to decode. This is easily usable in cases where you're trying to summarize really long documents, right? Parts of those documents that you've processed in the input are likely to show up in your decoded output. We want to be able to enable these things by default, run them sort of asynchronously from the model forward passes, and greedily use them as the as we get hits without possibly degrading performance if they don't turn out to actually be used during inference. So part of this is all related to sort of the re-architecture of V1 and changing the inter-process communication and asynchronicity of the different processes we spawn on the CPU and GPU for serving your model. Another really big thing that's really important to us is sort of better dealing with non-uniform KB cache. This is something that we expect will become more and more important as new model architectures come out that have different configurations for attention or non-attention or linear attention in each layer. Currently we mostly sort of deal with the assumption that each layer is going to have, the same number of KV cache blocks, or the same type of attention. And it's very clear from just some recent models like Ministral or encoder decoder models like Llama Vision, that we need to be more efficient here in how we're allocating our KV cache, and managing our KV cache for requests, and sort of dealing with the increasing non-uniformity of KV cache within model layers. Other really important things, particularly expedited by models like DeepSeek V3 being so capable, are general optimizations for MOE. I know the team at Neural Magic is working directly on some Cutlass kernels to improve on the Triton kernels we have for fused MOE inference right now, but also forms of data parallelism and expert parallelism that should help in getting more tuned MOE deployments. As mentioned before, with sort of the 2D block quantization, making sure we're tuned for Blackwell. NVIDIA, most commonly it'll probably be the GB200 configurations from NVIDIA. Just general performance readiness there, combined with PyTorch, but of course also being ready for the block quantization formats that FP6 and FP4 will bring, where they have 32 by 32 block scales. And then another thing that's really come up near the end of last year is making sure vLLM is well suited for RLHF workflows. We've heard more and more labs using vLLM, or projects in open source using vLLM and RLHF to speed up their workloads much faster than using vanilla PyTorch or transformers. Some of the key things here are making sure that we can update the weights of the model that vLLM is running with as it's running, and you don't need to, tear down vLLM and spin it back up with changed model weights, and we can just do sort of in place, in deployment, in situ weight updates, but also things like supporting reward models or fitting multiple models, like very tiny reward or value models alongside the larger model that you're deploying in one instance of vLLM. Kind of in a similar fashion that we have speculative models already, where we can have you know separate definitions for tensor parallelism for your target model and your draft model in speculative decoding. So those are some of the like pressing priorities. And then also on top of that, for also high priority, but slightly less, is getting structured decoding, structured output implemented in V1. This we've done a lot of work to make it performant in V0, but we still need to implement it in V1. And within that structure, we hope to take advantage of some of the optimizations that you can get from structured output, like jump decoding, where you can, because your grammar or like restrictions of the output that you have. If you're doing a JSON schema output or a code output, there's some sort of boilerplate tokens that could be at the end of key or value entries, and you could there's no need to run the model just to predict a closing brace. We can just skip ahead and just tell the model we know these things, and just schedule a short prefill. Another big priority is we have sort of basic prefill decode disaggregation implemented already, but there's a lot of flexibility that deployers, people that are trying to use prefill disaggregation want to deploy, where you have maybe multiple prefill workers or multiple decode workers, or different combinations of TP and PP for each one, and other things like storing KV cache on hierarchical storing of KV cache from GPU memory to CPU memory to disk to even databases. We want to get this to a level that that can be considered production ready, essentially. Another thing is in V1, we've basically started with support for image models, and we want to expand this to the other modalities as well, we actually hope that'll be pretty easy based on some current refactors that are happening. So don't be too discouraged that it's not a must-ship priority. And then general KV cache improvements. So this goes into things like KV cache quantization, KV cache sparsity, various compression methods, so that you can have more space for long context and get better utilization, more batching out of all these long context requests that you're trying to serve. And then, also here are some of the key development areas. Generally, model support. We want to support more and more models. There's actually a really promising PR from Arthur Zucker from Hugging Face, who's sort of making. They've done some refactors to transformers to their attention implementation that they think they'll actually be able to run, pretty much any Hugging Face transform model inside of vLLM through the Hugging Face model definition, which should be pretty interesting. Obviously, for the best performance, we'll still want to have our own definitions inside of vLLM, but this should, make it a lot easier for if a model is supported on transformers to have it, usable on vLLM and get the interface that people use vLLM for. There's also, of course, going to be a lot of work on hardware support. So, while we're always optimizing for the state of the art and most deployed models, which are NVIDIA, we expect to, see a lot more sort of time and effort put on allowing for more options in terms of the hardware that can run vLLM performantly. Particularly AMD GPUs and Google TPUs have gotten a lot of sort of interest and asks about, since they're starting to become more and more widely available on the hardware clouds. And of course, a really big thing is making sure that new hardware accelerators can also have an easy time to plug in and integrate with the interface of vLLM. So there's been some really good work recently on out of tree support, so we can maintain multiple different hardware backends without needing them all to live in the same upstream branch, and hopefully we can allow for even more hardware backends to you know offer the same interface for users in vLLM. And, this year more than ever, we're hope to have more community collaborations with our open source projects, with Hugging Face and Olama, and other open source projects we hope to see that built on top of vLLM and, use it as a building block to build larger scale inference structures, like distributed batch inference or, routers that are increasingly more sophisticated, um, to route between multiple instances of vLLM in a way that they're not just aware of the load that each vLLM instance is running, but also what do they have in their prefix cache, such that maybe this request won't add so much load. So yeah, that's most of what I wanted to get into. And now we'll get in through your little questions in the chat, or feel free to pop off on the voice chat as well. So 128 by 128 block quantization makes a lot of sense. Is there any analysis on curve for accuracy versus group quantization? Yeah. I wouldn't say there's really analysis, right? Like in that case, that's really something that DeepSeek, just chose to do, and in order to support the models, we wanted to implement it. So I would definitely recommend reading actually the DeepSeek V3 paper. They actually do talk about sort of why they made this decision. Um, Part of the reason is that block quantization, since they trained in FP8 and wanted to do the inference in FP8, block quantization is actually more efficient for training than group, because the transposition you need to do for your scales, when you're like sort of transposing your weights for the backwards pass, is easier. Or at least this is what they claim in their paper. It kind of makes some sense. But another thing is that like it is generally where we think performance in terms of uh, speed performance is going to go for hardware accelerators that want to have hardware support for these block formats. Um, there's a reason why they're going for for the microscaling, the MX FP6 or FP4 that NVIDIA and AMD are going to implement in their new GPUs. There's a reason why these are choosing 32 by 32 block formats versus 32 group formats. This is just fits more in line with how tensor cores operate on two-dimensional blocks of data rather than just rows or columns of data. Yeah, and then another question on less right: is it truly blockwise? Yes, it's like 2D blockwise on the weights and 1D or blockwise, or you could say like groupwise on the activation. So it's like dynamic per token activations, but in groups of 128. So you can have like multiple scales for a given token in the activations.
Got it. Okay, thanks.
Okay, I see you already kind of explained this in the chat with someone else. Yes, Robert, Red Hat lets us use Max. Okay, and then elaborating on the MOE plans. Yeah, so I mean, frankly, you can get a good idea for like why we think it's useful in a similar way by reading the DeepSeek paper on that. They have a pretty detailed section where they cover how they deploy their inference service. Of course, maybe it's not how they actually deploy it, but it's pretty reasonable. But basically, tensor parallelism is a really big problem for MOEs, and you really want to avoid this. Um, just naively, tensor parallelism, introduces communication for um, every weight matrix that you have. Um, sorry. Um, and with MOEs, you have like a lot of really small weight matrices for all your experts. So particularly in the case of DeepSeek, where they have dozens and dozens of experts, in comparison to Mixtral, where you have just like 8 for each layer. Um, DeepSeek mentions doing everything to avoid having tensor parallelism for their models, and rather choosing data parallelism and expert parallelism. Um, Now it's like a sort of challenging thing, because data parallelism and expert parallelism only pay off when you're deploying at a certain load and certain scale, um, because you're kind of spending more money on like having enough GPUs and having enough capacity to get like really good parallelism under load, and require like less. You're sort of trading off communication between a smaller number of GPUs for redundancy, and efficiency on a large number of GPUs, assuming you can get that load. But frankly, if you're like deploying a model that's 600 billion parameters, you're probably really trying to get a lot of use out of it, and really squeeze whatever money you can out of it. So it makes sense if we're going to continue scaling into larger and larger MOE models. Um, yeah. Oh. Um, yeah. From Richard, does vLLM compete with or work with Unsloth? Um, Unsloth, as far as I know, is sort of like a fine tuning project. They do like really efficient LoRa, QLoRa implementations. Um, I don't think it competes at all, because I think Unsloth just focuses on the training or fine tuning side. Um, we definitely have worked with them. I know within Neural Magic and some of the sparse models we've produced, they've been interested in working on fine tuning or producing LoRa's for those sparse models. So yeah, I think we're all friendly there. Um, yeah, vLLM works with Hugging Face, and it does have like support for GGUF quantization, like running GGUF models in vLLM. Um, yeah, I don't know if there's a map of the landscape beyond that, but uh, you know, most commonly, I think VLM. I mean, VLM also works with Mistrals. Uh, you know, Custom model definition and their tokenizers; those are integrated as well. So generally, I think we try to work with most open source model formats and tokenizer formats as they're heavily used. Um, yeah, IBM Spire. What about North Pole? I don't really know too much about either. But I know there is an RFC on VLM. So if you search in the issues for IBM Spire, you can see some of the IBM folks writing about their plans for that. So maybe ask them there. And then, yeah, from Robert, cache aware routing would be A++ for us. Yeah, I think it's more and more important um, as you get into those, larger horizontal deployments. I think, yeah, it's just a question of what's the right level for the BLM project itself to think about optimizations and to think about deployment recommendations. We don't want to become too much of a black box, or rather like too large of a black box. It's been pretty good for the project to stay at like hosting a single model on a single node or a few nodes of GPUs, and then leading that up to uh, you know uh, Kubernetes communities, or a Triton inference server, or other orchestration, or SageMaker, other orchestration methods for or modal for dealing with larger and larger horizontal scale out deployments of BLM. Um, but I think we're going to need to expand or address or make other projects that deal with stringing together multiple instances of VLM. Absolutely. So yeah, there were also some discussion questions that were given ahead of time. Thanks to people that submitted those. Let me make sure I go over some of these. Maybe I'll just do this here. Um, let's just zoom in really far. Yeah. So first one is like, is vLLMs ever enable hosting of multiple models on one server, a suite of small language models? Um, yeah, you can kind of, I think we've covered before, you can kind of hack this by, setting the GPU memory utilization to be small for each model and, get multiple models on a single GPU, just memory wise. But, you know, that's obviously not the best interface. I think, we're definitely planning on improving this. I know, like, one idea that was kicked around was, could we have an interface that allows you to spin up a model where we only allocate enough memory for one request? Basically, like, just enough memory to deal with the longest context length that would come in. Um, Basically, you should be able to basically in the case of where you set your max context like or right, your model obviously defines it, and you set like max number of sequences to one, we should have a way that we would only like allocate enough memory to support one sequence at a time at the maximum length. Um, so that would probably help a lot more people fit in a sort of more structured way of knowing how much memory is going to be allocated. Um, versus a percentage. But also, I think some of this will come from working with some of the RLHF or training workloads where people want to run like multiple models, multiple instances models for inference on a single GPU or you know single vLLM instance and sort of deal with loading or reloading that. Um, Yeah, a question on DLM being a very active project with lots of open issues. Um, what are the things we need the most help with? Um, I think one thing for sure is documentation. There you can always improve documentation. There's only so much work that goes into writing functional documentation, and there's a lot more work that could be done to write educational and nice documentation. Um, uh, A great example of that is Charles on here from Modal, who helped a lot with that wonderful GPU glossary, website, which I think is a fabulous example of aesthetic and educational design, um, which we could do a lot more of inside of VLM certainly, and we hope to as we try and document more of the architectural decisions we choose to make in the project, with V1 incoming. Um, Also, of course, I think things that we need most help with. There's a lot of uh, sort of small features or examples, like people complain a lot about small things not working with like LangChain or a lot of these libraries or like agent libraries or things like this. Really going for a lot of those. Um, Yeah, like integrations with VLM. These are only from external libraries, things that like VLM can't really manage. But like, oh, VLM needs some integration into like LangChain or Llama Index or Dispy or something. Um, these are only kept alive for as long as that project or that community keeps it alive. So, and those are really great ways to understand both a tool that's trying to use an inference server, and that could use some optimization or be good exposure for you from both sides. Um, yeah, Office Hours is a great reference material. Would it make sense to make a poll in Slack to see what features you'll want to deep dive on? Absolutely. We sort of tried it here in the presentation today. Definitely let us know what you want to deep dive on. But we want to ask more and more, and hopefully get more and more presentations from people from the community that more than just contributing to VLM, that are doing cool things with VLM and want to talk about that. We want to open that up. Yeah, is anyone planning to write a book on VLM? There's a market
know,
opportunity.
actually, I am. So
So Robert's planning it.
yeah, I've got a relationship with A-Press and Manning, and I've published twice books with A-Press in the past and worked with Manning in the past. I haven't pitched either of them on the idea yet, but I actually was planning on it in the fall. So if anyone else is interested and would like to do some co-authorship just to make life easier, I'm very open to that.
Maybe you could reach out to that Stas guy. I forget his name, but he writes like great resources on GitHub for
Buzz Beckman? Is that who you're talking about?
yeah.
No, I know Russell. Russell says it'll be out of the before the ink dries. That's like in the technical book writing.
Okay. Nice. Yeah. So like aside from trying a bunch of options in C or higher S, what are recommendations for tuning parameters for throughput? Yeah, I mean the same boring ones like, oh, you want to see like your max number batch tokens, yada yada yada. Um, but I mean really what we want to do here is as we mentioned in V1, just do a better job of improving default performance. There's a lot of better work we can do here. We were essentially kind of overall just too conservative and too worried about small inference GPUs and making these have bad token metrics. And sort of focusing on that and like losing the like throughput story. I think there's overall a much greater emphasis put on throughput in general. And if you're really worried about your token latencies, you're probably going to step in to make sure that you're meeting your token latencies. Your service SLA or your SLAs. So that'll be better in default. But one thing that I certainly take pretty seriously and personally is that one thing that's like greatly missing that we've tried to automate a bit is having a reference performance page where we go through and we show under a few different workloads, here are some common configurations, pre-tweaked knobs, where, okay, you want vLLM for like a really teapot, really inter-token latency optimized configuration. Like here's what this looks like on an H100 system for a reference model. And, here's a really like token throughput optimized one. These are just things that, of course, they're not going to apply to like your specific model and your specific GPU setup, but it should at least give you some like, reference. Oh, I should be within 20% of like this performance or, is my performance an order of magnitude off or just 10% off? This is, just a good a viable reference for people to have and just understanding what's the performance of vLLM like. Uh, yeah. Um, yeah. And a similar question, like, do default configurations work well across various GPUs? Um, yeah, I mean, this is sort of yes and no. Like I said, it's kind of a trade-off you want to make. Generally, we want to make it now targeting the like state of the art, so H100s. And then after a year or so, it's going to be, the B100s or B200s that are really going to be the target. This is most important for us because this keeps us aware of any overheads that aren't the GPU. So like keeping up for CPU overheads, which is like our job to keep down. Um, in terms of making sure, oh yeah, are we like sending batches that are too big for the GPU? This is something where, in the future, we may be sending batches that are a little bit too big for, smaller inference GPUs, but we can also set up heuristics for this. This is, not something, it's not hard to find out what GPU you're on. And, we hope to, or, it's easy enough to make a sort of dictionary or lookup table for these things. But, overall, I think defining and making some things like a reference performance page that not only shows you the metrics and like where things can fall apart in certain configurations, but also introducing you to the performance metrics that you should be looking for. I think will just help you make better decisions. And yeah, shout out to GuideLM, a cool interface that we worked on. If you have any issues with it, open out. We're happy to keep working on it. But there's many solutions for benchmarking. Most of us just use the benchmark serving script in the benchmarks folder. Yeah, this last one, actually, I have the least clue on. So Charles, if you maybe want to talk me through this a bit.
Oh yeah.
And Yeah.
I can take this one offline, but yeah, the OpenAI API server, um, there's nothing that exposes something that, like, creates that API server in a way that you could, like, attach it, like, attach middleware to it, except functions that take, like, an arg parse namespace. This is very, like, in the weeds thing,
Yeah.
but I think just a little bit of work to restructure that so that there's, like, a command line interface, but also an easy way to, like, import a function and not have to, like, construct an arg parse namespace on your own, would make it a lot easier for us to, like, serve the OpenAI API server, like, programmatically rather
Okay.
than via command line interface.
Okay. Yeah, that makes a lot of sense. Yeah, we should fix that. I wasn't even aware, but it makes sense that we kind of just have a CLI for the API server. Yeah. Well, I think that's most of what we had. Yeah. Are there any other questions that we possibly missed through? Yeah, I think that's pretty good. Um, so yeah, that's all we got for today, and we're at time. So as always, thank you all for joining today. Next 2 weeks, we'll have a great talk on distributed inference. So definitely give that a peek if you're interested. But as always, you know, contribute to vLLM, become a user of it, bug us on the GitHub, bug us on Slack. This is how we know what's most important to work on. And definitely with respect to, this roadmaps slide, you know, go to the issue that's linked here and comment on that. We're, forming the Q1 roadmap right now. We're just talking openly about it. And if there's anything that, you would really like to see prioritized, we want to hear it. So yeah, give us any feedback on office hours, how you want to see it grow or better serve you this year. We have a channel in the Slack if you want to talk to us about it or propose anything. And we have a lot of meetups coming up. So I think these dates are slightly off, Sasha, but we have the first vLLM meetup of the year in San Francisco on January 22nd. And then we have a meetup where both myself and Charles from Modal, we're going to sort of do a full stack coverage of open source AI between Neural Magic, Modal, Dot Text, and one more,
Neo4j.
Neo4j, where we'll cover, from the bare metal to the application level, um, how you should think about deploying open source AI. That'll be on the 23rd. And then we'll also do the first East Coast vLLM meetup in March over at Google's campus, I believe. So it'll be pretty cool.
Yeah, more info to come in a few weeks once the other two meetups are over. We don't want to pollute the message, but you'll be hearing about East Coast meetup very soon.
Yeah, definitely it should be a nice one. And as always, we're hiring. If you want to work on open source vLLM, we are very much still looking for people. So